think we are live. Oh, one moment. Are we live? I cannot see if we are live or not. Let me see here. Just one moment. Yes. So, hello. Hi, I'm Dr. Maria Sulindro, integrative anti-aging and from Pasadena. One moment. Pasadena, California. With the growth of epigenetic, above the testing of genetic testing, people are more aware that knowing about their DNA will be very helpful in controlling their healthy aging. Today, with me is Dr. Andrew Miles, who is the CEO of a genomic company that is maintaining more than 600 medical doctors widespread in 3 continents. Welcome, Dr. Andrew Miles.
Thank you. It's a pleasure.
We are very blessed to have you today to share with us the knowledge of the update on genomics. Before we start, do you mind telling us how you become interested in genomics when you do not even have any medical background?
Is maybe a little bit of a foot down? No, I'm just kidding.
First, just a second, Dr. Andrew. I think your voice needs to be a little bit louder.
Can you hear me right now?
A little bit more, please. Can you?
Sure. All right. I want to thank you for the invitation, though. It's a great honor to be on this Facebook Live, and you know, the magic of technology. It's very cool to be able to reach so many people using this. Can you hear me okay? Good. Dr. Maria, you're able to hear me okay?
Okay, go ahead.
Right,
yes,
cool.
yes, go ahead.
So thank you for that. But as far as the background, yes, right from the beginning, Dr. Maria pointed out that I actually don't have a medical background. I have a PhD in computer science. And that may be an unusual choice for what we're talking about here today, or the guest that Dr. Maria normally has. But if I can explain a little bit. So my background is in the analysis of data. I've worked in a number of different organizations in big data and artificial intelligence before that term became as infamous as it is today. But anyway, I discovered genomic data about 10 years ago. A professor at Harvard Medical School, Dr. Manish Gala, actually brought it up to me. It's his research area. He's a longtime friend of mine. He brought it up to me and I took a look. He said that fundamentally genomics is a big data problem, and the techniques that you've been using to study other data maybe could be applied to genomics data. So I was looking at it a little bit, and it seemed very interesting. Of course, there are other people that have started with DNA analysis, people like 23andMe and so forth. I'll talk about those more in a bit, but the more I looked at it, the more excited I got. When you think about it, each person has 22,000 genes, each person has millions of mutations, and in total, several billion base pairs of DNA. That's a lot of data. And when you look at the research papers behind this, there's now tens of millions of research papers. And it's growing exponentially. It's growing faster and faster. And there's tens of thousands of different medical conditions. So how do you sort, prioritize, filter to combine all of this data and to have something that makes sense, right? How can you make sense of all of this data? That's what really struck my fancy. And the deeper that we looked into it, the more excited I got, number one. And number two, the more I felt like there was an opportunity. I felt like that we were doing something that other people had not explored before, and we could unlock more value for our clients.
Wow, okay. So, you know, to me, when you first came to my office, it was 7 years ago, and I subscribed to your amazing testing. And could you please share with us the background of this testing so people understand?
Yeah, thank you. So what we do is we analyze all 22,000 genes and the full length of each of those genes. And you think of DNA, it's of course what made you, the original blueprint that all of your cells then derive. So, of course, people are familiar with DNA testing now. 23andMe used to advertise on TV like every hour, and they used to say you can take our test and find out what ethnicity you are or what percentage Neanderthal you are. Those are, fine things if you're so interested. But because DNA is the blueprint and creates everything, there's so much more information you can get out of it. So that's just the tip of the iceberg. So what a company like 23andMe does, although they were great innovators when they started about 14 years ago, they just measure small portions of the DNA, very small. And in fact, it's less than 0.01% of what we measure. Again, we measure the full length of all of your genes.
Wow.
So with that, we apply our computer algorithms. These computer algorithms that get me so excited, what I love to work on, and then we try to make sense of those mutations. And what we try to do is we try to find something that is really, really significant for each person. And it might be a risk for a particular medical condition. We'll talk about those in a moment. It might be a new way to manage your life, right? It might be that we're able to find this particular food or this particular environmental thing, like exercise, might be ideal for you in becoming the healthiest you possible. That is our goal. So not just kind of fun things, which we do, not just things like what percentage Neanderthal are you or what ethnicity, but we try to get real value, things that will, I would say, potentially change your life.
That's what I'm interested in. Just focus on the health and how to help people to grow older and healthy. Now, because you mentioned several name of the companies like 23andMe, can you give us a little bit background or synopsis of your company, the NAG?
Yeah,
I know
absolutely.
it's a one now widely adopted in the whole genomics DNA. Yeah. Mm-hmm.
Right. So we started off about 7 years ago, yes. And as I mentioned, it was a partnership, me as the computer guy, loving to analyze the data, and our medical co-founder, Dr. Manish Gala, coming together and looking at how we can make DNA data usable, actionable, valuable for the medical setting so that doctors can use this to help you live the best and longest life possible. That was our mission. It took iterations, it took many iterations. And that just goes to show that this is a difficult problem. This isn't something that, you can just kind of work on weekends and kind of figure it out. It's something that you have to take a lot of refinement. As you just mentioned, we now have 600 doctors in our network. I'm very proud of that. We're the world's largest full-scale DNA test. Very proud of that. And the doctors in our network span every different category you can imagine. So Dr. Maria, for instance, an anti-aging type of doctor. You have many different specialties, Dr. Maria. I wouldn't want to just say one. But anyway, also have doctors that are internists, cardiologists, oncologists, every different specialty. And this matters because it teaches us how to apply genomics to these particular fields. And through that iteration, through these years, our test has gotten more and more accurate. So we give the best results to each person and more powerful. So when we give a result to someone, we can say, okay, here's what you need to check for. And then here's what you can do when you find it. Very important. What are the next steps afterwards?
And also that once you have the result and you give it to the patient and the doctor who prescribed it, they own the portal. Am I correct?
That's a great point. That's absolutely right. So one of the unique parts of our approach is that we're not just a one-time test. So most of the medical tests that you order, you just get it once. So for instance, a blood test or, a urine test or any other genetic test for that matter. You just get it one time and those are your results. You get it on a piece of paper probably. We are very different actually in that our test, it's actually a program. You actually become a client in our program. And what I mean by that is we get your DNA on file, and then we reanalyze your DNA every 2 weeks based on the latest science. This is important because, as I mentioned, the body of science on genomics in particular is proceeding at an exponential rate. It's absolutely bonkers how fast it's moving. And it means that if there's a new paper that comes out tomorrow or the day after that or what have you, that is relevant for your particular DNA, we notify you, you get update for that. And so it's protection for life. This is a system that's with you your entire life, and it evolves, it gets smarter and smarter.
Yes, thank you, because you did that to mine also. Thanks so much. And since we are dealing with publics on this YouTube information, maybe you can tell us what the difference between genetic testing and genomics. And the word is used interchangeably. I understand that. So I would like to clarify that from beginning. Yeah, go ahead.
That's a great question. Yes. So genetics and genomics both refer to DNA, obviously, but the context in which they're used is very different. So genetics, a term going back over 100 years. If you remember, Mendel did pea experiments. He was a biologist over 100 years ago, and he said, we're going to look at the genetics of the color or other properties of a pea. But genetics has also been used in situations where maybe a child has something very rare and very serious, sad typically, and a genetic disorder might be something like a Huntington's or like a cystic fibrosis, very, very serious diseases, and you would know whether you have them or not. So if you're someone who's watching this Facebook Live right now and you said, oh, those sound very scary, I hope I don't have that. If you don't know you don't have it, you don't have it. Those are so serious you would have figured out very, very early on in life. Genomics is different, though. Genomics is a term that's used differently. Genomics, yes, it still refers to mutations. It refers to how your DNA is different from other people, but it's used in the context of it's not just one mutation causes a particular issue. It's often many mutations work in tandem and then cause an issue. So a great example would be like a heart disease. So heart disease, there's not usually there's not just one mutation that would give you heart disease. Usually it's a combination of different mutations. Usually there's also a bad lifestyle that's involved as well. So the larger term genomics incorporates multiple different mutations together, incorporates what you eat, how you treat your body, all of these different factors together. It's much, much more complex, but it's much, much more relevant to most of us, right? Most of us do not have a severe genetic disease, but all of us, to some extent, our genomics is impactful.
I see. So it's the the story about the gene and the person and the environment that can involve and affect the genetic problems.
That's right. That's the most exciting area of genomics research, of DNA research, is the overall genomics is how do all of these pieces fit together? And a good example is think about you versus your parents, right? And obviously your DNA is a little bit different from your parents and it's a combination of your parents, but you still have 50%, you share 50% of your DNA with your parents. But it's not the case that every single disease they get, you're going to get, or vice versa. It's not. Obviously, there's significant correlation, but it's not true always. And why is that? If you share such similar DNA, why is it that you might avoid a disease one of them has? And of course, that's to do with all of your other mutations. And of course, that's how you live your life. So if you're somebody who exercises a lot better, maybe you exercise, it doesn't even have to be more, but maybe you just exercise in the smarter way. You exercise in a way that's actually genetically suited to you. It's a topic we may be getting on to later, but maybe you just happen to stumble on the exact right thing for you, and one of your ancestors did not, and your ancestor got the medical problem and you avoided it.
Wow, okay. So since you mentioned about this 23andMe genetic testing that was introduced like, when was it, like 14 years ago, like you said, okay. Can you tell us the big difference? I know you said it's less than 1% that they tell the clients about this, your test and that, but what is the main difference? Is it like Ancestry, or what is the main difference, 23andMe and NAG?
Right. So there's many technical differences, but the high level difference between them is 23andMe is a toy. I don't mean that in a bad way, but it's something, you find under the Christmas tree, the holiday tree, something like that, right? And you say, would you like to just learn a couple of fun things about you? Ancestry is fun for people. A couple other traits like that are fun for people. That's cool. No disrespect for that, but it's more like a toy. And the difference is our organization, it's like a tool to help you live as long and as best as possible. Do you want to live to 100, 120, or possibly even longer? Some of those technologies exist right now, and it may happen. Our clients now might be some of the first that live to 120.
Okay. So, Dr. Andrew, what is the most remarkable thing you have seen in person's DNA? Can you share with, because you're not a doctor, so I'm just wondering if you can share with
Right. You'd like to get me to try to pronounce a medical term, and then I'll do it incorrectly. And no, I'm just joking. I'm just joking.
You know everything now, you know, you don't have to go to medical school.
The computer algorithms help teach me. That's right. I'm learning as they help teach me. But I would say that most of our clients are in the category I was just talking about. They're people that have generally good health. And, you know, maybe they have a couple of lab values that aren't too great. You know, maybe they have high LDL. Maybe they're a little bit overweight. Maybe they have an ancestor, like a father or mother that died early, and they're just, you know, wanting to prevent a similar thing from happening. Most of our patients generally have great health, and we want to give them the edge, right? We want to take them from, you know, if they're achieving 75, 80% of their capability, we want them to achieve 100% and then live as long as possible. That's most of our patients. But, you know, if you say the most exciting, so I don't want to keep you all day, but I'll just give you one or two most exciting ones. All right, so here's one of them. I remember there's a patient from San Francisco who was in his 70s, and I won't go through all of his symptoms, but suffice it to say, he's been to every different doctor. He's taken test after test. They had no idea what to do with him. And everybody in the office, they love him. They say he has such a nice personality. They're like, I don't know why such, you know, a bad thing would happen to him, but we just can't figure it out. And they came to us and they said, can you use your computer algorithms on him? So we analyzed all 22,000 genes. We have special algorithms for people that have unusual things going on. We evaluated every single mutation. We found a very rare one. We found a mutation that only 2 people in documented human history have ever had before. And we were able to figure out that he has a weird sort of issue, and I don't mean it in a I don't mean to take offense. Unusual, I should say unusual rather than weird. But in terms of that his nerves were being degenerated by a particular biological process that gets very involved. But in any case, we figured out where it came from, and the cool thing about it was that there is a supplement called L-serine. It's a type of amino acid that he could take that would fix this issue. So it's crazy that we got to the bottom of his particular issue that every other test, he could not figure out what it is. And it was just as easy as a supplement could help reduce that. I'd say that's number one. I'll give you one other example. We had a young gentleman in his 30s. Unfortunately, he had metastatic colorectal cancer, and that is so unfair. You know, colorectal cancer, I mean, obviously, as you get older, it becomes more likely, but to get colorectal cancer in your 30s, that's unfair. You know, it just shouldn't be that way. And he was at the point where he had tried every other therapy. It failed. He was out of options. And he said, just, can you give me anything? What we found is that he had a particular broken gene, and by broken, I mean totally non-functional. So not something that could ever be picked up from a 23andMe or one of these other tests, but just a dramatic biological change in his body. It was another super rare mutation. I think he was the only one to ever have this mutation. And we were able to find out that this gene relates to cancer processes, and colorectal cancer in particular. It's likely the cause of his cancer. And what's more, here's the kicker, is we are actually able to find that there's a drug that interacts with this particular gene and might be a new therapy. So we gave this guy a new therapy, possibly a new lease on life. And you know what? I checked, he actually has a Twitter account. I looked him up online. He's still tweeting. He's still alive. That was the best feeling. It's been about 2 years. He's still alive. So
that's the reward. That's the reward,
right.
knowing that whatever we do helps people to continue their life and healthy, right? Yeah. So Dr. Andrew, would I really want to know about my genomic is one of the questions. Is that kind of like maybe scary? You want to tell them because, you know, I think it's only appropriate because if you tell them, because you have seen so many people now change their mind and they want to know about their gene now.
Right.
Of the epigenetic. Yeah. Mm-hmm.
That's a great question. And I mean, I'd say for starters, there's that difference between genetics and genomics that you brought up earlier. And most of us, if you're walking around and you're somebody that, you know, feels like you have good health, if you go to the doctor and the doctor says you're doing well for yourself, I think you should have some confidence in that. I think that most of us, generally speaking, are pretty healthy. And if you had one of those scary diseases, things like a cystic fibrosis or a Huntington's, generally speaking, you would have known early in life. You would have known very, very early. This is not what we're talking about here right now, by and large. What we're talking about more is diseases of aging, right? We're talking about cardiovascular disease. We're talking about cancer. We're talking about Alzheimer's. And to be honest, every one of us is potentially at risk for one of those things. Every one of us has some risk. It's important to find out what your risk is, though, because people have different risks. And it's important to find out where that risk comes from, because if you do, then there's a possibility that you could counteract that, possibly even reverse that. And Alzheimer's, I just brought up, is probably one of the most exciting things. So cardiovascular disease, I'd say really for the last 30, 40 years, we've gotten a good handle on cardiovascular disease. We understand where it comes from. We understand that there are certain diets and exercise and so forth. And, you know, if you do have a heart attack, there are ways to recover from it, et cetera, et cetera. Cancer, we're starting to get more of a hold on. Alzheimer's, I wanted to say, that's kind of the most exciting. Just in the past 2 years, there's all sorts of new research. So people have thought, well, you know, there's nothing I can do if I learn that I'm positive for Alzheimer's. That was true maybe up until 2017. That's not necessarily true here in 2020. There's all sorts of research. For instance, if you have a particular marker called the ApoE marker, there's been some research that says that the Mediterranean diet could be more beneficial for you. That's an easy thing that you could adopt, and you could slow down this entire process. That's just one example, but overall, the field of genomics, it's going so fast. There are so many more and more studies. I would say that the vast majority of time, when we find something that is problematic about a person, and a risk for a disease of aging, that we're able to then find that there's a diet, a supplement, a food group, something like that, that's able to counteract one of this. I would say that everybody should know their DNA. Everybody would want to find out how they could avoid these particular things.
Yes, thank you. I mean, I know we only have like we don't have to rush because we have other questions too. But let's answer this one because I think they missed the name of your company. It's NAG, New Amsterdam Genomics.
Yes,
right?
And you can go to our website, www.nagenomics.com, newamsterdamgenomics.com.
Let's take one question here. Okay, is this for prevention and detection only? How does this work with current diagnosis, such as cancer? Well, we mentioned that already, and reversal of problems, and you are answering this now. Okay, so is there anything else to add? That's a physician asking, Dr. Cynthia.
Oh, okay, great. Yes, so it can be used in one of two ways. So the first, most of our patients, as I mentioned, are generally very healthy. Most of our patients, you know, maybe they have a couple lab values that aren't quite perfect, but to a large extent, very healthy. And they want to know what are the diseases of aging, the cardiovascular disease, the cancer, the Alzheimer's, this sort of thing, that it might be a little bit more at risk for, and what are the ways to avoid that so I can live as long and as healthy as possible. Most of our patients are in that category. But we do have a lot of patients that have a particular thing going on. So as I mentioned, that had a patient with a really unusual circumstance who was in his 70s and he had taken all these lab tests, didn't know what was going on. We love those patients too. We spend extra effort on them. We go to the ends of the earth to find out if we can help those particular people. And if you have a family member that has something going on and you want to find out if you have a similar risk, that's another kind of intermediate case. But we also try to figure out where that might come from.
Thank you. Let's just answer one more question, if you don't mind, okay? So this, does your test cover all genetic mutations? I think yours is the most, right? In the market at this moment?
Right. So we cover the full lengths of all 22,000 genes. And I wanted to say that crucially, not just do we measure them, but we analyze them as well.
Yes.
So I would say, what good is the data if you don't actually analyze it? I think that's a very important point, because the data itself, just knowing A, C, G, and T at a particular locations, that's pretty much useless. And considering you have billions of base pairs, you could never pore over these by hand or that sort of thing. But we've built computer algorithms that actually analyze this. And the things that pop up on our system are sometimes very unusual. And not necessarily unusual in a bad way. I just want to clarify. I actually have something very unusual in a gene called the von Willebrand factor gene, which means that I bleed a little bit differently. And it's not a big deal at all. It's just kind of a way in which I'm a little bit different. But this is a way that, because we analyze all 22,000 genes, we're able to pick out that kind of obscure thing I would have never have thought to check. I wouldn't have checked for that myself, but I'm really kind of pleased that I figured out that about myself.
You want to introduce at least one more word, that broken genes, remember? I was surprised when you came one day, a year later, you said, oh, Dr. Maria, we found broken gene in your system. Okay, you want to define what broken gene means?
Thank you. Yeah. So I wanted to emphasize that there are many different types of mutations. And the mutations that you'll find on a 23andMe are, generally speaking, they're what called polymorphisms. So there are ones that don't dramatically change the resulting protein or your overall biology. They usually change this by about 5 or 10%. That is to say, they might increase the activity of this particular gene 5 or 10%, or decrease it about 5 or 10%. And some of those can have some effect, but by and large, those aren't that important. The most important ones are the ones that are very rare. So if you find an aspect of you that's very different from the average person, that's very, very curious. That's something that you'd really want to know. And as I just mentioned, in my particular case, that von Willebrand factor mutation, that does happen to be very rare. I'm actually one of only 4 people in the world to have this mutation. That's how rare it is. But it isn't scary. It's not a scary thing at all. It doesn't affect my lifespan at all, but it's something that it causes me to bleed a little bit differently. I am very happy that I learned that that's kind of the basis of it, and there's not anything like deeper going on. But we all have weird, unusual things is the better term. And this is a test that brings that out, whereas something like 23andMe, which just looks at polymorphisms, just will not turn out these really unusual, fascinating things.
Let me clarify. So you're saying that when you say broken genes means mutations?
Yes, I should have gotten to that point.
Yeah.
So a broken gene, I mean, instead of these 5 or 10% change in activity level, I mean 0%. A broken gene is something where the activity of this particular gene is totally absent. This is a gross biological change in a person's body. And in fact, it's normal to have broken genes. As you know, I'm trying to emphasize, even healthy people like me have broken genes. But if you have a broken gene in an interesting place, it can cause something that will be very different about you than for the average person. It's important to really figure out where these rare mutations are. That way you can get the most interesting findings that are most impactful for you.
Okay, so is it the same then? Mutation means broken?
I would say mutation, it's some of these terms are used imprecisely, and broken gene is, of course, not the technical term for it. The technical term is called a truncated gene, actually. But mutation, yes, is considered to be a change in your DNA that's bad, right? And there can be different types of mutations. I would say the most dramatic mutation are these broken genes, are these protein truncations. Those are most likely to have a significant effect in your body, if that makes sense.
I see. Okay. Okay. So just for my personal interest here, can the broken gene be improved by any other means like lifestyles and things like that?
Yes, it depends on the gene, of course. But the fascinating study is that many of these genes, even when they don't fully understand what they do at the time of the paper, many genes actually have been studied in different, for instance, in mice and cellular, that sort of thing. I don't know why a particular scientist would, study some gene that they don't even fully know and decide, oh, let's give this supplement, let's give this, food, this sort of thing. But there are so many studies like this. And it's likely that if you have a gene that is broken, that's truncated, it is likely that there is actually a study that says there is something that you can do to fix that.
Okay. What do you see the future of genomics?
Yeah, great question. So I think that as we've seen the evolvement between or from genetics to genomics, as I mentioned, genetics is the idea that you have one mutation and then it causes something very, very severe to the point that it's hard to live. And genomics is different in that genomics is about many different mutations, potentially. It's about environmental, et cetera. And I think that's a trend that's, it'll go even more in the sense that it won't be long, maybe just a couple years, when we'll look at your DNA profile and we say you have, let's say, a 53% chance of having a heart attack by this particular age, that's, let's say. But this 53% can be reduced to, let's say, 17% if you start eating strawberries every day. I don't know. Everybody is different. But that is to say, our predictions of these risks are going to be so fine-grained that we'll be able to model and we'll say, here's how you should change your diet. Here's how you change your exercise. And to this level of precision of each individual foods. And then you can maximize your chance of living as long and healthy as possible.
Wow. Yeah, I think that's the reason why there are so many people subscribing to the test. This year, I heard that it's about like 50 million compared to like 2013 when it was only 1 million. That's what I read. I don't know if that's true, but that's according to when I Google like Mayo Clinic, whatever. So now let's just review one more thing here about this epigenetic and genetic, because I'm going to probably do a separate epigenetic and what that one is. But from your genomic study, so you include the epigenetics advices in each of the explanation if they have an abnormal result. And my understanding is that epigenetics will overcome the possibility of their genetic expression by 98%. So that is very significant. What do you say about it?
I might not put an exact number, 98%, but I'll say, just going back to the example of comparing your health outcome, let's say, versus your mother or your father's health outcome, and you share 50% of the DNA, and not every single disease that medical condition that your parent gets, you'll get. Why is that? It's because, of course, that you have other mutations and you have other environmental inputs as well. So I think that's a very striking demonstration, just very easy to understand how environment is so important. Now, in terms of our results in particular, yes, so the most exciting area of genomics research, I think all of genomics research is exciting, but the most exciting, I would say, is in modulating these particular genes, right? So we have a general sense now, many genes we can say, well, this particular gene relates to heart disease. Let's say this particular gene relates to von Willebrand factor, the blood thing that I brought up earlier, or this other particular gene relates to a certain type of cancer, let's say. We have some kind of large sense on this, but more recently, there have been all of these studies. I mentioned that they're often done in mice or they're done in cells as well, but they say with this particular chemical, often a natural chemical like a supplement or a vitamin, that sort of thing, you can change expression by doing something or another. So as we figure out kind of how are these switches, right? If you have by birth, maybe you have a switch turned off, and we say, okay, you take this particular substance and now you can turn the switch back on and get yourself back to where the rest of us are, that sort of thing. That's the most active and exciting area of genomics research.
So Dr. Andrew, some of the DNA testing, for example, like the BRCA1, BRCA2, all those series about this in cancer and cardiology, I know your test is also approved by the FDA, but why they can be covered under the health insurance and not yours? Can you please explain a little bit? Because many people ask me and I don't have an explanation.
Yes, so health insurance is its own thing. Of course, there are all sorts of different providers and they operate a little bit different state by state. Of course, each plan within insurance is different. Each person has their own circumstance. So I would say that the health insurance coverage is not uniform at the current time. I'd say that what we do is on the absolute bleeding edge. So we're about using technology to get the most amount of DNA data you can out of your DNA. And because we're on the bleeding edge, because we're trying our analysis in so many different circumstances, the regulatory, the kind of bureaucracy, let's say, has not necessarily caught up with that. That being said, there's a couple of rare situations in which this testing is covered by insurance, but it's just a matter of time. I will predict, you can hold me on record, and this video will be saved in perpetuity. So we will see, but I will predict within approximately, let's say 3 or 4 years, that if you have cancer, this test will be absolutely standard. It will be the go-to test, 3 or 4 years. And I will predict that within 7 years, every single person will have their DNA covered. But if you want to know your information now, and I would highly recommend that, so you can make adjustments now, so you can learn, so you can get ahead and do what's best for you, it's out of pocket.
Okay, thank you for that explanation. And there are other gene testing or genomics testing that are not covered also. I understand. And yours is like very humongous. It's very big. 22,000 is big numbers. Now, let's just use, we are over 30 minutes, but let's just answer these important questions here. They are very curious, right? Is this initiated with a blood test or saliva test? I think yours is saliva.
Saliva, yes. Mm-hmm.
Saliva testing. And then does this help with stress-related disorder?
Yes. Yes. Stress is another environmental input.
Well, covers MTHFR also, right? So that
yes.
That is also part of stress, yeah?
Right.
So the answer is yes.
Yes.
Yeah. So they asked if I do this in our office. Yes, for 7 years already.
Got yes, a lot of experience. The answer,
yes. Mm-hmm. Can you determine if there is endothelial dysfunction with this genomic testing? That's cardiology genetics, right?
Absolutely.
Yeah. Okay. What does this test cost? Do you want to tell them how it works? And how we it's prescribed by physicians, so maybe some of other physicians will charge more. right?
Absolutely, right. But you bring up a good point, which is to say this is a doctor-ordered test. This is not something that you can just kind of find on the internet. Now, obviously, we have a website, but this isn't just something where you spit in a tube and then it goes off to wherever, and then who knows the quality checks that are behind it. This is serious. This is important, impactful information. This is a real tool to better your life, to become much healthier. And as such, we have had to go through multiple rounds of government inspection. So inspectors have literally come into our lab and they've said, show me everything. We've had to, shuffle through papers and all of this different things to their satisfaction. So regulators from the US government, from different states, California, actually flew all the way across country just to investigate us. And I'm happy to say that all of the findings were completely, we aced it, but they were very, very thorough in checking us.
Excellent. I would like to congratulate you as a young doctor. You can cover all these, this aspect of health, and it's a very interesting to witness that your background is computer science, right? And then now you're involved in a lot of these health issues. Well, thank you for updating us with the genomics here and your company. And anything else you want to say before I close?
I look forward to seeing you all as clients. So I hope that everyone considered this. And I think it's a very exciting world that we live in, that all of technology, it's advancing so fast. And I'd say genomics is one of those areas that's advancing the fastest. And you think of all of the great things that have happened, for instance, with your smartphone over the last 10 years, that's what's going to happen. These technologies are going to go to your genome over the next several years. It's going to be really exciting.
Thank you so much, Dr. Andrew Miles. I'm Dr. Maria Sulindro, Integrative Anti-Aging Medicine in Pasadena, California. See you next time. Bye-bye. End this thing.